Continuing with number 14, 13 divided by 6. 6 goes into 13 twice, which is 12. And then you have 1 left over, so 1 over 6. So I know it's real. I know it's rational. I know it's not an integer. I know it's not a whole number. I know it's not irrational, etc., etc. So these two would actually be the same answer. And again, double check your notes, and that way you can kind of identify what you know. Okay, more on order of operations. So again, I'm going to write PEMDAS here, just so that we are aware. Okay, so 6 plus 76, which is number 16, minus 8 plus 28. And again, reading from left to right. So I get 82 minus 8 plus 28. 82 minus 8 is 74 plus 28. And 74 plus 28 is 102. And this is my answer. Okay, so I'm not going to do 17, 18, or 19 because they seem pretty much the same. I'm going to move on to the next section. Okay, in the next section it says find the product. Product means multiply. So really you could just use your calculator. What I need you to remember is two negatives, right? A negative times a negative is a positive, and a negative times a positive is a negative, and I'll erase this. Oops. Let me just erase that. Okay, so a negative times a positive is a negative, and then a positive times a positive is obviously a positive. So I'm pretty sure you could do this section all on your own. If the number of negatives is even, then you know it's going to be positive. If the number of negatives is odd, you know it's going to be negative. So in number 20, there are 2 negatives. That's an even number. You know that the answer is going to be positive. 22, there's an even number of negatives, so you know the answer is going to be positive. 21 has 1, 2, and 3, so that's 3 negatives. You know my answer is going to be negative. And that's it. Moving on to the next section, it says find each quotient. We know quotient is division. I need you to remember that when you are dividing fractions, you keep, change, and flip the sign. What do I mean by that? So let's try number 23. So I'm going to keep, change, and flip. I'm going to keep this fraction the same. I'm going to change the sign of the division to a multiplication, and then I'm going to flip the second fraction. So we know that -1 is actually over 1 right now, and I'm going to flip it. So flipping it would be 1 over -1. Now, in order to solve this problem, I'm going to walk around the clock. So I'm going to change that mixed number into an improper fraction. So 2 times 2 is 4, and 4 plus 1 is 5. So I really have 5 over 2 times 1 over -1. And now you just multiply across. So 5 over -2. And usually we put our negatives on top. So my answer would be -5 over 2. And some people always ask, why can't you flip the first one and then keep the second one? And it won't work that way. You'll get the wrong answer all the time. That's why I tell people to remember, keep, change, flip. And if you're like me, you probably think of chicken with KFC because it's very similar, so KCF. Okay, so let's try number 24. I'm going to change this to an improper fraction. Keep the negative on the outside. So I'm going to leave that negative alone. And 8 times 2 is 16. 16 plus 1 is 17. So I have 17 over 8 times, and I'm going to flip that. So that's 10 over -9. Now, to make my life easier, I'm going to cross cancel. And I can cross cancel whenever there's a multiplication sign. I cannot cross cancel when there's an equal sign. So side note over here, if I had 2 over x equals 3 over I don't know, 9? Yes, 3 over 9. I can't, well, actually, no, let's change that. Let's change it to 2 over x equals 7 over 8, for example, right? A lot of people will try to cross cancel the 2 and the 8, and in this case you cannot because of that equal sign. But if the problem looked exactly the same with the multiplication, and I'm using the same numbers, then yes, I would be able to cross cancel, and this would be a 4 and this would be a 1, and so my answer in this case would be 7 over 4x, whereas in the first example, and I'll highlight, in my first example, I would have to, whoa, that's a very dark highlighter. Okay, let's go back. In my first example, which is here, I would not be able to cross cancel. I'd be cross multiplying. Okay, so going back to my number 24 problem. So I cross canceled, and I'm going to divide by 2. So this becomes a 5, and this becomes a 4. So now negative 17 times 5 is negative 85 over negative 36. There's 2 negatives, therefore I can just cross those out because a negative divided by a negative is a positive. So my answer is actually 85 over 36. Or if you wanted to change that into an improper fraction, you would say 2, because 2 times 36 is 72, and 72 would give us 13 left over. So 13 left over 36. Either one of these answers is fine. Okay, so moving on to the next section, you are distributing in this case. So I'm going to distribute to everything in the parentheses individually. So number 27 is negative 16x plus 40 plus 6, and a negative 6, or a positive 6 times a negative 8x would be negative 48x. I know that these two are like terms, and because they have the same sign, I can add them together and keep the sign. So I know this is going to be negative 64x plus 46, and this would be my answer. I can't divide by anything. I can't simplify because it's an expression, not an equation. So let's try to do the next one, which is 28. And 28 has a 2k. So 2k times negative 6 would be negative 12. And a k times k is k squared. You add the exponents. Okay, so 2 times negative 7 is negative 14, and you still have that k there. I'm going to do the same thing here for my negative 3. So negative 3 times k is negative 3k, and negative 3 times a positive 3 is a negative 9. Very similar to the last one, I have like terms. These are the only two like terms, so leave the 12k squared, negative 12k squared alone, minus 17k because they're both negative, so I add and keep the sign, and then I leave my 9 alone, and this is my answer.